So $848.1 billion. I'm just going to write a couple versions. You need to write 3 versions. So 848 and then a comma, and billion is 3 groups of 3 out there. So I'm going to put a 1 and a couple of zeros and then a few more zeros and a few more zeros and double check. Right, these are my ones area and my thousands area and my millions area. So the 800-ish is in the billions area. All right, so that's one way I could write it. Scientific notation wise, I would like it to be 8.481. Decimal point has to go just to the right of a single non-zero digit. And then we have to multiply by a power of 10. Right, so we have 3, 6, 9, 10, 11 places there. So that's what I think it would be in scientific notation. You come up with another way to write it. We're going to play around. So with credit card interest rates, and often I get these in the mail all the time. I don't know if you guys do, where they say, hey, we'll give you this great deal on a credit card. Your interest rate will be this or this. And they offer some other things. Generally, the interest rate on credit cards is based on what's called the prime rate. Did anybody read to see what prime rate means? No. Well, take a look at your worksheet. It's in there. Let's see, they got a little footnote here, says number 2. And if I look down here at number 2, it says prime rate is a base interest rate that banks charge their commercial customers. Right. So prime rate changes. So sometimes you might have an interest offer on a credit card that could be based on the prime rate, which is dangerous. So prime rate is a base rate that banks use. More specifically, it is an annual percentage rate. And they apply this to customers, like you and me. And a warning about prime rate, for those of you who don't have a lot of credit card experience, some cards will make offers like prime plus 5.99%. And that's what they're going to give you. Prime is reevaluated every month. It's actually evaluated every day, but the conditions maybe say every month. So 5 years ago or 4 years ago, prime rate was probably around 3 or 4%. So 3 or 4% plus 5 is going to be like 7 or 8, 9% interest. That's not bad. Anybody know what prime is today? It's a lot more. I don't know what it is. I'm going to look it up. Prime. Oops. Wait, Google. Look it up. Prime rate. What's happening today? Commerce, current prime rates. 8.5% is current prime rate. So compared to a few years ago, it was much lower. So right now, today, prime is 8.5%. So combining these two together, we're going to get, when we add those up, we're going to get 9 and 0 is 9, 9 and 5 is 4, carry the 1, 6 and 8. That would be 14.49% is the rate that they would charge you this month for October, for example. If prime goes down next month, yay, good. But now you have a floating interest rate. It's not the same every month. So if you are trying to budget carefully about any debt you might have in a credit card, having a card that's based on prime rate is not often helpful. Now, a lot of times, though, they lock in your credit, your interest rate based on a credit score. So it could be here, you have a really good credit score, and they're going to give you a rate of 10.99%, regardless of what prime is. Right? And you just get that for as long as you have the card, unless something goes wrong. Anybody know what could go wrong? You miss a payment, you don't pay the interest. So there's usually conditions in there that they will up your rate when that happens. But I found often if you have good payment history on a credit card, you could call the credit card company up and say, hey, I'm going to switch over to another credit card unless you lower my rate. And sometimes they will. So it's always worth asking. But beware of interest rates that add on prime to a given percentage, whereas these are fixed percentages here. All right, so main thing you need to know about prime, it's an interest rate that almost all banks base their credit stuff on when they have new customers. And again, for some people, it doesn't matter because they have a fixed rate on their account. Other people, it does matter because they have a variable rate, prime plus something. We got next. All right, so APR, I wrote on the previous page, that's annual percentage rate, and it's a rate that applies to the whole year. When you get some kind of credit offer, generally, but not always, it's a fixed rate, which means you are stuck with that rate for the terms of the length of whatever agreement you have with the bank that's offering that. So for example, we might have a good credit score and get the lower 10.99% rate. Now, this is important. The rate stated on a credit card is an annual percentage rate, APR, and that is the amount that applies to a whole year of money sitting somewhere. Now, generally, you're billed on a credit card monthly, so then there should be a monthly rate. So monthly percentage rates. And there are a few ways to deal with a monthly percentage rate. One way would be just to say, well, there's 12 months in a year, then the monthly rate should be 1/12 of the yearly rate. So the monthly rate here could be 10.99% divided by 12. Let's whip out a calculator, see what that is. Yeah, it'd be a little less than 1%, exactly.
But wouldn't it just be like, 10.99% of?
No, because the 10.99 only applies for a whole year.
That's what I'm saying, but
Yeah.
it's still 10.99 of what you make that month.
Divided by 12.
It's not a lower percentage of.
Yeah, so here's.
10.99% of what you make every month.
No, every year. That's the difference between a monthly rate and error. So let me do a calculation. Hang on, just let me catch up. So I'm calculating 0.9158. Let's take 3 decimal places there and call it 0.916 for this one right here. So this is approximately 0.916%. So like Anthony said, it's a little less than 1%. Okay. Just gonna make a note. Slightly less than 1%. Okay. Now, to address what Anthony was mentioning, to make sure I'm speaking the same language, let's suppose you have a balance, a monthly balance of $1,000. What happens at the end of the month?
I don't choose, because I was thinking more of income than not balance.
Yeah, so here we're not looking at income, right? We're looking at, you have a credit card balance, is what I'm looking at. So at the end of the month, the bank says, okay, you've had $1,000 that you owe us that's just been sitting there. And you owe us 10.99%. But that's only if a whole year went by. It hasn't been a whole year, it's only been a month. So they're going to divide that by 12 to figure out how much you owe. So back to my calculator. I could use the unrounded amount above and just take, yeah, it's going to be $91.60. So multiply that by $1,000. I'm just going to take 1,000 times my previous answer there. Well,
You rounded it.
What did I do wrong here? Oh, this isn't a percentage yet. So I need to divide by 100 because it's a percent. So this would be $9.16 to the nearest cent here, would be what I owe on $1,000.
Yeah.
Just for this month, yeah. So at the end of the month, what'll happen on my bill is they'll say, okay, previous balance was 1,000, current interest is $9.16, and then they give a recommended payment. Now, the recommended payment is usually set up so that if you paid that amount every month for like 3 years, you would pay this off completely. Now, it varies from bank to bank how they calculate that, but usually 3 years is pretty common. Sometimes it's 5 years that they calculate the minimum payment, and then they round it to a nice number like $35, something like that.
So to find out the, what would be like the APR on that, would we be able to multiply that 9.63?
Well, the APR here is fixed, right? So bottom line is the APR on this particular credit card account is 10.99%. So if I owed $1,000 on that account that month, and if that balance was fixed for the whole month, then this right here is how they would calculate the interest I owe. So that right there is the interest owed for that month. And then I'm expected to make some payment, okay? And calculating how to make that payment is more complicated. If anyone goes on and takes 105, Math 105 later, we'll go over how to calculate that. But there's a formula for it that all banks use. So let's just say, for example, the bank says your minimum monthly payment for this month, and again, this is a little beyond what's on this assignment, but this is important information. And again, this is a wild guess. I'm just going to say they're going to say it's like $35. I'll calculate it later to figure that out. So then you pay the $35. What happens? Well, currently you owe $1,000. They just added on $9.16. You send them $35. They take that away. So now what's the new balance? Calculator, please. It would be 1,000 plus the $9.16 I owe them for interest minus the money I sent them, which is $35. So now my new balance is $947.16. And then what's going to happen at the end of the month? Well, the end of the month, they're going to say, okay, we're going to take that. Oops, forgot to hit answer. They're going to take that amount. They're going to multiply it by the interest rate, which we have as about 0.916. Divide by 100 because it's an interest rate. So I owe them another $8.92. I pay $35, and then my balance goes down a little bit, right? So what's going to happen for the next month? I would have that 974.16, and this would be more fun on a spreadsheet, but I'll do that later. Plus, I owe them $8.92, and oops, plus. And then I send in another $35 and I owe $9.48. My balance isn't changing a lot. Right. So just making the minimum payment is painful, takes a long time to pay it off. And I'm paying a lot of interest. I mean, $9 isn't a lot, but it's not a little either, right? What'd you say, Anthony? Sorry. Yeah, it's going in the right direction for sure, but it's going slow. And usually banks do like, when they estimate your minimum monthly payment, they're putting you on like a 3-year plan or a 5-year plan to do it. You should always pay more than the minimum monthly payment if you can. All right, let's get back to our assignment here. So we calculated the monthly rate. I went to 3 decimal places. I see now it says 2 decimal places. So if I were you, I would make a statement here that says the minimum monthly rate is, I'm just going to do that cleaner on a new page. So for my number 3, I might say something like the monthly payment, interest rate, monthly rate is about, so the 2 decimal places we would have 0.92, right? and that's a percentage. Now, I'm oversimplifying this a little bit because most people on their credit card, they buy new things each month on their credit card. A lot of people try to pay it off. So your balance changes throughout the month. So what would happen then if it's not a fixed $1,000 per month? There's a way they calculate your average daily balance, and basically then they apply a kind of a daily rate instead of a monthly rate to that average daily balance, and they come up with a similar number. And usually people don't pay on their credit card in between the monthly payments, so typically your balance is either fixed or rising during that time. Okay. So they use an average daily balance for that, and they use a daily rate instead of a monthly rate. Other thing, do all months have the same number of days in them? No, so it's going to be a little bit different in February versus January, because January has 31 days and February has 27 or 28 days, depending on the year we're in. Okay, so there's a little variability in that, but this is basically the right idea. It's around the same amount of money that would happen in your credit card. All right, what do we got next? So we got credit worthiness. So there's a credit score that's calculated by various credit agencies based on your past history with credit. If you have no credit history, then unless you get a deal like a student offer credit card or you're going with a parent, then you're likely to have the higher interest rates. You get some good credit history. So beware. So we got Juanita, who gets the lowest rate for the card. So she would be at the 10.99 rate. And so here we're just asked to make a rough estimate of what she would have to pay on $1,000 for the month of January in interest. So I did $1,000 earlier. She's got a 5,000. Don't calculate it, just estimate. Just write a number down. I think her interest amount will be, put a number there. And the next one will actually calculate it. By next part, I mean next question, not next part. Sorry. We're going to do a few estimates here. So if you got an estimate for what she is going to owe just in interest for a month, what would it be for a whole year? Up your estimate by 12 for the next part. And then we're going to do the same thing for Brian, who gets the highest interest rate of 23.99, I believe it was. Yeah. That's this again. Question number 4 is estimates. And then in question 5, we're going to do some calculations.
Letter C and D say calculate, not estimate.
Okay, so there I knew we had calculate somewhere. Thank you. Okay, so where Brian will calculate. There we go. Brian, his APR is the highest one for C and D, 23.99%. And again, here we're going to calculate the interest amount. January. And that's on the same amount, $5,000 in the account. And part D is interest per year. So for Juanita, it's just under 1%. So a good easy estimate would just be call it 1%. 1% of 100 would be $1, right? And she has $5,000. 1% of 100 is $1. 1% of 1,000 would be $10. So 1% of 5,000 would be about how much? You got this? $50. Yeah, it'll be about $50. 12 months goes by of $50 each. How much is our estimate? Now, if she did really wait a year to make a payment, that $50 in interest gets added back onto her account. So now for the second month, she has to pay interest on $5,050. So that means the interest for the next month is going to be a little higher than 50. That gets added on. So that's called compound interest, and things are going downhill if payments aren't made. Because the interest that you owe collects interest too. That's bad news. So the rough estimate again would be 12 times 50, but it's going to be much more than that once you add on the interest on the interest. All right, calculate. Let's make sure we get Brian's calculated properly. So I am going to whip out a spreadsheet for that. You could do a calculator or a spreadsheet. There's another spreadsheet part to this assignment, so it's recommended. And I can go borrow some computers if anybody wants one. Let me know.
We do one with you right now, we still have to do another one.
Another spreadsheet?
Yeah.
You don't have to do a spreadsheet for this, but I think it's a good use of one. And then the next question asks, how would you use a spreadsheet to make a calculation? So I just want to demo that too. So this is lesson 1.9, and feel free to follow along here. And I just want to keep track of the balance and the interest rates. And then I'm going to have the monthly interest and the yearly interest. There. Oops. Wrong other. So the balance here, I'm going to call this sheet Brian. Double click on the tab at the bottom to rename it. So Brian has $5,000 that he owes. His interest rate is 23.99%, the highest one on the credit card offer we were given. And so to calculate his monthly interest, I'm going to write it down on paper and then put it in my spreadsheet. That's going to have to be the $5,000 times the 23.99%, but because it's just for a month, we're going to divide that by 12. Because it's 1/12 of a year, 1 month is. So that's the calculation I need to make. On the spreadsheet, though, I have 2 of those numbers, so I don't need to retype them. I just type equals, click on his balance. Google is suggesting I multiply, which is a good suggestion. And then I want to multiply by the rate, but then I got to adjust it for a month by dividing it by 12. So Brian is going to owe $99.96 on that 5,000. And the yearly rate interest is going to be similar. I just don't have to divide by 12. So I'm just going to start over equals, take the 5,000, multiply by the yearly rate, and I'm done. It's going to be 1,199.50. Now, that is not completely true. Blow it up a little bit. Because what's going to happen is after 1 month, that 99.96 gets added to his account. And if he doesn't make a payment, he now owes 5,000, about 5,100, and I was going to pay interest on that. And if he doesn't make a payment, that gets added to the account, and this is just gonna escalate. Okay? And that is called compound interest. So again, if Brian didn't make any payments, he's actually going to owe a bit more than that right there. But that's what's that?
Sorry, how come your spreadsheet doesn't round up the 20 to 24%?
So if your spreadsheet started doing that when you started typing, then go to one of these buttons, this one right here. So if it came in like that, just increase the number of decimals you're seeing, and then it'll display it correctly. Yeah, so sometimes your spreadsheet will auto round for you. If you want to change the number of decimals shown, then just increase the number of decimals shown. It should work out.
And you just multiply the 5,000 times the...
Yeah, so for the monthly formula, I'm taking the 5,000. So I just clicked on that cell, times, click on this cell, and then slash to divide by 12, because it's 1 month, 1 out of 12 months in the year. So again, repeating that, I type equals, I click on the 5,000, and then I multiply, and I click on the interest rate. And then I can divide by 12, because it's 1 month. 1 out of 12 months in a year. The next formula is just equals the balance times the APR. So this is the answer to part C, and this is the answer to part D.
Then you get the yearly one again?
For the yearly one, all you have to do is multiply the balance times the rate, because the rate is the annual rate. So equals, click on the balance, times is the asterisk, click on the rate. And then just hit enter. You just gotta have the equals first for the calculation to happen. All right, what's next? All right, so we got that information there. We're going to discuss the following. Jeff pays the highest interest rate for cash purchases, highest interest rate for purchases. For cash advances, he would pay 5 cents more for each dollar he charges on his card. So let's see about that. So again, I'm just going to scribble a couple things down to answer this. Let's do just Jeff first. That's new page. So let's see, Jeff, we got paying the highest rate for purchases. So Jeff is paying at $23.99 like Brian was. Anybody with this card though is going to pay this much for cash advances. So here, this is claimed to be 5 cents for each dollar. So thinking about that, 5 cents per dollar is just 0.05. If I take dollars divided by dollars, they cancel. Okay, so this right here is a rate, but it's not a percentage rate. To turn this into a percentage, how do we turn a regular number into a percentage? Anybody remember from before? That's to change a percentage into a number. The reverse is multiply by 100, yeah. So if I take that right there times 100%, oops, that's going to give me 5%. So another way to say this claim, again, the claim is for a cash advance, he would pay $0.05 or 5 cents more for each dollar. 5 cents out of a dollar is 0.05. As a percentage, that would be 5%. Is it true that this rate here is 5% higher than that right there? Yeah, that's true. it's true that 28.99% is 5% more than or higher than 23.99%. So yes, it's a reasonable statement because it's true. All right, so what's next? Louis, not her, pays the lowest interest rate for purchases. If she purchased a $400 TV using a cash advance, she would pay about 2.5 times as much interest as if she would have used the card as a regular purchase. All right, so this one I'm going to let you play with. So calculate what would Lois, it's probably Lois, there we go. What would Lois pay in interest on this TV if she does it with a cash advance versus a regular credit card purchase?
Yeah. Oh, what does she pay?
Yeah.
Or can we just say, yes, she does, because 29% is 2.5 more than 11.
That's a good answer right there. Okay. But I'd appreciate it if everyone would do a calculation too, just to check. So again, my question is, if she does a regular credit card purchase at the lowest rate, how much interest is that? If she does a cash advance purchase at this rate, how much interest is that on $400? Then we will confirm this right here. So we'll look at it a couple of different ways. So I'm going to do this on my spreadsheet. The idea is the same on a calculator. So we know the TV is $400. If she does a regular credit card purchase at the end of the month, they're going to charge her this rate for 1/12 of a month or year. If she does a cash advance at the end of the month, it would be this rate for a month. So the interest amounts, I should be that clear, interest amounts for a month. 1 month would be equal to the 400 times the interest rate divided by 12, because I'm just letting 1 month go by. So I don't want to fill this down because it's a little more complicated. So that would be 366. If she uses the cash advance method, then she is going to start at 400, multiply by the 28.99%, and then divide that by 12 because it's 1 month. So that would be 966. All right, so is it a bunch more? The answer is yeah. It's going to be a bunch more interest for 1 month. A year would be a lot more than that. Back to the statement here. She would pay about 2.5 times as much. Okay. Whenever we looked at questions about how many times one thing more was another, we would divide to figure that out. So to figure out the times difference, spreadsheets. We could do it here too on paper. So times difference, or times more, I guess I should say. We always took the bigger number and divided by the smaller number to figure out how many times more something was. So the bigger number was $9.66. The smaller number was $3.66. Whip that out on a calculator. They claim it's around 2.5 times. So just gonna make a note here. Times more equals this number divided by that number. And I'm getting about 2.6 times more. That's around 2.5 times more. So yeah, that's a reasonable statement. Now, here's the deal though. In the calculation, what was different to get the 366 versus the 966? Well, like Anthony pointed out, the $400 is the same. It's these numbers that are different. So he claims you can just divide these two numbers to get the same answer, which I totally agree with. So let's try that. So times more with the percentages would be just to take the 28.99, I need the equals in there, and divide it by the 10.99. And we should see if we get it out of percent format. So if the computer ever formats something as a percent and you don't want it, you got to go to format and then switch to a regular number. And so there I'm getting about 2.64%, okay, which is a rounded version of that number right there. So either way, it agrees. And if you had calculated the yearly interest and divided them, you get the same exact answer, about 2.6 times.
Yeah, and about 2.6 times quicker too.
Yeah, it's a lot more money. All right, so this statement does seem reasonable, and there's several ways you can justify that. Either you're going to write down this version of the calculation or the division with that version of the calculation. You choose. So write something down for that if you haven't already. All right, so let's see. Brian, my recollection is he had a bad credit rating, which meant he had a high interest rate. So he was at the 23.99%. What does the divide by 12 on that percent mean? Why are we dividing by 12? Anybody remember?
Monthly.
Because it's, yeah, that calculates the periodic or monthly APR. And what is this? B2 plus B3 plus B4 plus B5? What's that about? Yeah, those are the individual charges here. So if I go to my version of the spreadsheet here, I should add these up and then multiply by the percentage per month. And that should give me the interest paid. So again, your goal, so this is calculating the monthly rate, the periodic rate. This is adding up his charges. And then we just multiply the rate times the amount, and that gives us interest. Which statement is best? You pick. Feel free to check with a neighbor on that one. And then we're going to come up with a couple of other formulas to make this calculation. All right. And before I do that, I want to try my spreadsheet. So again, the interest, the percent, the APR isn't shown on the screen, so I have to type it. So I'm just going to go equals 0.2399. I think is the rate I want. Yep. Divide that by 12. Now, in the worksheet, they put that in parentheses. And we'll talk about whether I need the parentheses or not in a minute. And then you can use the arrow keys to move around. So if I start over, every once in a while I do a formula and realize I didn't type something right. And you can usually point and click in the box to fix it. So I should have equals parentheses 0.2399, divide that by 12. That gives me my rate. And then I want to multiply that by another parentheses where I just click on these one at a time and put a plus in between. So I'm just going to click, plus, click, enter a plus, click, enter a plus, click, enter a plus. No, that's the last one. I was on a roll with plus in there. There's nothing else. Close the parentheses, don't do another plus. All right, so this calculates, it should be $2.43. for a month with those things on there for all of the days in the month, which would be about 31 days. Okay, other ways to calculate that. So what I would rather do is add these up first and then multiply by the rate. And have I done a formula where I add stuff up before in here? I don't think I have. The formula for adding stuff up is sum. So what I'm going to do is I'm going to go equals and I'm going to type sum. And here's the cool thing about sum. I don't have to click them one at a time. I can just select all 4 of them at once, which is easier to do. And then just close the parentheses. That's going to add them all up. Then I can multiply that by 0.2399 and divide by 12, and it should be exactly the same amount of money. But that's a slightly easier version of the formula. Okay. So I would recommend writing this down. Yeah, this is one of them. Write that down.
Flip it around pretty much.
Well, I use sum, which is easier to type. Yeah, so use sum. So it goes, yes, write down what I typed.
I got it.
Wait, so you want sum?
Equals sum. Yeah, so let me do that over again. So let me just delete that and start over. So equals, and then start typing SUM, and you should get a bunch of different sum formulas. I want that first one that's just sum. So then select it. It puts in the parenthesis. If it's not suggesting what numbers to grab, highlight from the middle of the first cell, drag down to the middle of the last cell, then let go, close the parentheses, then multiply 0.2399 divided by 12. And we see I get the same amount.
What's another one? It's kind of fairly simple because it's just flip it around.
Yeah.
So you give it one.
Yes. Yeah.
Sure.
I'm sure I could give you 10 more if you'd like, but I'm not going to give you 10 more. Now, someone could have calculated the interest on each thing, like how much interest on gas, how much interest on groceries, how much interest on the restaurant.
They want to do a lot of writing.
Well, no, I'm just offering that as a suggestion. Okay, so I'm going to offer some other suggestions. Okay, so in my notes here, I'm just going to abbreviate this. So you could write it just like this. And here's my claim. You don't need parentheses. You don't need all of the parentheses. So I could type 0.2399 divide by 12 and then multiply by the sum, parentheses, B2 colon B5. And the colon means use everything in between. Don't mistake it for a comma, which would skip stuff. Okay, so I'm just going to make a note up here what not to do. Do not do this. If you tried to do sum, parentheses, B2, comma, B5, this would only do B5 and B2, but not the ones in between. The colon is super important if you want to do a range of numbers in between. Okay,
What about just like the mine? Oh, no, the no mine is.
Yeah, so, and again, this is a slash here. That's a slash for divide. And that's slightly different what I just did in the spreadsheet, isn't it? So there's another way to do it. Somebody might do the yearly approach, which would be to start with the sum, B2 colon B5, multiply by the interest rate, 0.2399. Oh, we already did this one, didn't we? Oh, I could add extra parentheses. My computer's being weird. This calculation right here is the yearly interest, and then I could divide that by 12. That's a slightly different formula. So we now have 1, 2, 3, 4 different formulas we could apply. There are others. One I mentioned was we calculate each of these separately times the interest and then add them up after. So I wouldn't recommend writing that one down. It's a lot of work. keep repeating that. And then add them up after. That would be the worst way to do this.
Wait, so for that, right under that, on the actual worksheet, what do we write? The answer?
So here, the worksheet asks us, for this part right here, write two other formulas we could use to calculate the interest charged.
Oh,
So one of them I gave here. So that's one of the formulas I could use. And then two other slightly different formulas I wrote in the notes a moment ago. I just want you to write down two other ways we could tell a spreadsheet to make this calculation. So that's one possibility. Here's two other slightly different possibilities on how to make it happen.
but we don't have to write anything. Right here, I'm gonna see.
You just have to pick one of those. Which of those is the best explanation of this formula above here? So 6 I or I, which one best describes the calculation that Brian used? And just circle it. And then, so for example, in question 6, one of these best describes this formula right here. I want you to explain down here what's happening in one of the formulas you wrote. What's going on, for example, this one.
Explain a completely different formula you want me to write down the next one too. I just pretty much
Explain one of your formulas. Yeah, I don't care which one. Yeah, any one of them. Yeah, just in words instead of symbols, what does the calculation do? And then question 9, I mentioned the idea of credit score. What can affect your credit score? Well, not having much credits, overcharges, late payments, yep. Not paying your balance off quickly enough, that can affect things.
Late payments, yeah.
Yep. If you've ever been reported for not paying a doctor bill on time, or fraud, or like not paying your rent, if that ever went to court. Anything related to money that could be in the public record could affect your credit score.
Absolutely.
Like I was a month late on a $30 doctor bill once 10 years ago, and it's adversely affected my credit. Enough so that when we went to refinance our house a few years ago, my wife said, "You're not going to be on the refinance because your credit score is not as good as mine." The interest rate was like 1% difference on the house. That matters because houses are expensive.
Yeah,
You know? So be careful.
I'm native, so I pretty much got like super boku insurance, right?
Yeah.
But I went to the hospital for, I'm just not gonna say, and my tribe was supposed to hit that bill, but I ended up getting the bill in the mail, and then I ended up going to jail or something, and then went into collections.
Yeah.
Oh my gosh.
Yeah, so that, I mean, that happened to me on a $30 doctor's bill. They sent me to collections, I forgot to pay it, and it killed my credit score. $30 killed my credit score, so be careful.